Hi folks, I'm Imtiaz Chaudhry and today I am giving you the first lecture on CCNA 200-301 and the topic which I have chosen according to the syllabus is the OSI layer model first. We all know that the way the computers or the network is working without any trouble, so there has to be rules and standards which we call protocol or the firmware. So irrespective of the operating system which we use in networking, well, mostly they have to follow those rules. So the software is being written according to those rules, the devices are being manufactured according to those rules, and then the application or the system is converting those things according to those standards. So the first standard or the model, which came into being in 1983, which we call OSI reference model, the Open Standard Interconnection. This was by the open, because by its name, Open Standard means it was from ISO, International Standardization Organization. So the object was that when the communication is being used, there has to be a standard rule, standard protocols. This is like driving. If you are driving in North America, so you know you have to be driving in the right side. But if you are doing in Europe, England, then they drive in the left-hand side. So basically the rules. Or when it is a stop sign, red light, you have to stop. When it's green, you move, keep moving. And when it is the yellow, that means you have to be careful. So similarly it is, when the computer networking devices are working, they have to form the rules. Now the first one here is now, they have divided according to the layers. Though there are 7 layers. These layers are, if you read from bottom up, so bottom up means physical layer is layer number 1. Data link layer is layer number 2. Network layer is layer number 3. Transport layer is layer number 4. Session layer is layer number 5. Presentation layer is layer number 6. And application layer is layer number 7. Now, so application layer is basically exactly where the user has the interface with the services, with the applications. So clearly now we have to figure out what are the application layer protocols, because this is where the client is going to have interface with the application. Now, what type of application? For example, the browsing, or the email, or you want to resolve the Google's name, or you want to download your email, or you want to send your email. This is the user interaction. So clearly, there are protocols which are dealing with those. So which are the main protocols at the application layer? Remember, protocol is a wide area term. Is a term which can be used in any one of these layers. So make sure, you must know that it is application layer. And what is the application means? If I am running a client-server application, like a browser and a web server connecting together. So if I'm using a browser and I want to connect with the web server, so clearly I am using HTTP protocol. Or if I am sending email or receiving email, so we know that SMTP or POP3 or IMAP4 is being used. Or if you want to go do the FTP, file transfer protocol, so you are sending it and then there is server where you have storage and you want to download it. So clearly application layer means the user, the client, server, access point, interface. Number 2, so basically what the user is doing is, user is generating the data. And that data which user is generating, we generally call it a PDUs. Okay, protocol data units. So this data can be created or in any format, whatever you are doing it, in language or whatever you are doing it. The next layer, they define the presentation layer. Presentation means how system is going to go and format that information. So formatting that information, whether system is going to convert that into ASCII code, And that ASCII code, I just want to make sure you look into all these things. So when you are presenting, ASCII code means American Standard Code for Information Interchange, or you are using a JPEG like things, or you have some other format. Maybe you want to encrypt it, you want to decrypt it. So this is the layer where they define that the information is going to be presented to the other side, the receiving side. If it is not formatted properly, the other side, the end computer or the end client won't be able to decrypt it or won't be able to access that. So clearly when the data is flowing in this way, application and then is presenting is formatted according to one of these formats, whichever is being used. Then the third one is called the session layer. So this session layer basically means is control the dialogue between the computers. So main idea is it establishes, manages, and terminates the connection. Now what it means? This means if you call somebody on your phone, so clearly you are dialing in, the other guy is picking up the phone and then responding back, and then you start talking. And once you have done it, so you want to say, well, okay, we will talk tomorrow or maybe next time. So you break the call. So this clearly means that a session layer system is controlling and managing your connection. Another example, maybe from your computer, you are having www.google.com, you are also doing FTP, you are also sending email, so you are having different type of session. So system is keeping track of all those sessions which are open from your end to the other end. And when you have done it, it will close it properly. So these three upper layers, which we say application or presentation or session layer, basically, they are done by the software engineers, developers. So clearly, if you are being trained to be a developer, software developer, so this is where you work. You create these things. And this is where people are being hired for all these things. So if you are a developer, if you are a software engineer, this is where you work on, and then these applications are going to be used. Now all these three applications or whatever we are saying here is they are all client server based applications. So client means which is running the interface, which is seeking for the services, and on the other end there is server service running. So client and a server connection. So clearly this is the application layer or presentation layer or session layer which is being used from process to a process. Clearly it is between process and another process. Who's developing, who's taking care of all this? As I said earlier, the software engineers, the developers. We use it irrespective of your operating system, irrespective of your browser, whether you are using Firefox or using Chrome or you're using Internet Edge or Internet Explorer, doesn't matter. This format is same. That's why they form the general consensus or the open standards for compatibility. Now once we have done it now, so whatever the information is being generated here is passed on to the next layer. So if you look here, OSI is 3 layers. Equivalent in a TCP/IP, they just call it application layer. They say, well, why we have to call 3 things? Because all these 3 things are done together and they make it as one layer. So rather than calling 3, they say, well, application layer, that means here where the client server applications are working, the browser is working, or you are using Outlook, you want to send a message, or you want to telnet, you are executing some command on a remote computer, or you are forming a session. This kind of session means maybe you are having transmitting and receiving at the same time, or maybe the session is you are only transmitting but not receiving at the same time, or the way you are formatting information. We all know that, for example, MP4 or JPEG or ASCII code, this is where the system or the data is going to be formatted so it can be presentable. Next comes now this information, this data which we generate here or from here is going to be presented to the next layer. Transport, how you want this information to be transported. Now this application which it generates, like HTTP or SMTP or POP3 or whatever, which transport layer they use to transport that data. Because data is being generated here, and now you have to have some kind of format, some kind of mechanism to transport that information. So at this layer, at a transport layer level, what we do is we are using two protocols. This is between host to host. Remember, transport layer is between a host to a host. A computer to a computer, like you are a browser, whatever you want to send the information to this web server. System is formatting, system is creating the sessions and all that, and then it has to be formatted, your HTTP information, according to this. So the transport layer provides the data between the end user. That means that you are sending me email, or I am sending you email, or you are accessing the Google, and Google is sending you their web page. So data transfer services at the upper layer. So what are these upper layers? You can see there. You have presentation, you have application, and you have a session. Now this one controls the reliability of your link. So the information which you are getting, the communication which is flowing between the client and the server, this layer is taking control of that. It is going to make it reliable. And how does it make it reliable? So there are two protocols which are being used as a transport layer. We call it a TCP, and the other is called a UDP. So TCP is called Transmission Control Protocol, which is reliable, which needs acknowledgement, which keep control of the flow. This is how it goes. So that makes it reliable, because you are putting sequence numbers. So every packet, whatever information you are sending it, it is always as a sequence number there. And then on the other side, you are segmenting your information into different parts, and then you label it, segment it, put a sequence number, and send it to the other side. And when the other side receives it, it is going to go and reassemble it, and then it's going to present to the other side. So this makes it reliable, and this is how the data flows. And the other protocol, so most of the application layer protocol like HTTP, Simple Mail Transfer Protocol, FTP, Telnet, they all use TCP as a transport protocol. The other one is, if you don't want to use TCP, because like in video and voice and all that, you want to send the information, you don't want any kind of delay. So they use UDP, User Datagram Protocol. So it doesn't need any acknowledgement, it doesn't care about the sequence number, you keep sending it, because you don't want any delay. So at a transport level, or at a level, that means these two protocols are taking care of the information which is being sent from the end users, from A to the B, from A computer to B computer, browser to the web server, Outlook to the Exchange server. The next level is now, once you have done it, the next level the work here is on the network layer. So network layer is basically where you are going to go access the network. This is the logic comes into picture. So that means basically up to these four layers to the top here, as a user, I don't have a control, I just use it. I just use it. It's always at the background, which I'm using is. At a transport layer now, we have to find the path. We have to find the path. And how do we find the path? By using the network addresses. Like when you write a letter, you send a letter to somewhere, so that means your address and the destination address. So on the left top the corner, you write your address, and then in the middle, you write the destination address. So source address and the destination IP address, which never changes. Which never changes during the transfer of the information. So network layer addresses never changes. These are the logical addresses. Your IP address and the destination IP address never changes while the information is being flowing. So this is where the system is using the main protocol, which we call IP, ICMP, ARP. So IP is the main thing, the internet protocol. By internet protocol, we find the path, we figure out the IP addresses, the source addresses and the destination addresses, whether this message is for my local network or this message is for not my local network, that means for remote network, then I may be using router, those kind of things. If you are not sending outside of your network, then you are not using a router. The next layer is the network layer now. Now this comes physical. So whatever we have been doing up to that was all logical. Now you come here at a physical thing. So if you don't have a network card, if you are using a LAN, you have a network interface card which we say Ethernet. Or if you are using a wireless, you are using a wireless card. So clearly the wireless card and the LAN card has a physical address which is a chip. You can read it in hexadecimal. System can read it when you boot your machine or you boot or you switch on your phone or whatever. That means system is going to read from the chip into your RAM. Now these addresses are from link to link. IP is from the source to the destination, same. The network, the transport layer here is, which you are using, this should be up and this should be down. This one is, or maybe it is a duplicate. Yeah, this has to go up. So I've gone a little too far. Network layer, no, not there. It is under transport. This one. Transport layer, physical layer. Also I missed, so we can put it back, no problem. And this is your network layer. Then as I was saying, the data link layer. So clearly now the part of the data link layer is, so you are using Ethernet or wireless, for example. So these are your physical addresses, which we call MAC addresses. Media access control, physical. It is from a link to link. So that means your source address and then your next link's destination address. When it goes there, then that machine changes the source now. So now its own address becomes the source, and then the other link's address becomes the destination address, which they keep changing. So we generally call it at this level. That's why it says from link to link. And then it's going to pass out this information is going to go to the physical layer. So physical layer is going to translate whatever information is being given here is into the signals, into bits, into voltage, 0, 1s. And it's going to send the information to on the cable or on your air, if it is wireless, the radio frequency, converting these things. So these 7 layers are basically modular. People are working on different layers. They don't mess up with the others. So each layer is passing the information to the next adjacent layer. So application layers sends it to the presentation. This sends it to this layer. This sends it to the transport layer. Transport layer sends it to network layer. Network layer is sent to the data link layer. And data link sends it to this one. So within a machine, these are called adjacent layers. So system to system is only TCP. only the TCP, transport layer, that is going to provide the system layers. So you are a browser, Google is a web server, so TCP's job is from host to host. Because this is, you are sending it, they are collecting it, they are reassembling it, and then it makes sense. So here we call data in these three levels. We call it encapsulation method, we call it a PDU method, the way we are encapsulating, the way we are wrapping information, or the way we call it a header, you are putting extra information. Transport layer is segmenting it, chopping it down. Network layer is giving you the packets, or we call it a PDU, protocol data units, or we call it encapsulating. Data link layer is doing the frames, hardware things, header and trailer, and is sent to the next link. Physical is converting everything into bits, 0 and 1s, voltage. So all this process is called encapsulation. So you are encapsulating. When this information goes to the other machine, the same thing happens in a different direction. And this is called a de-encapsulation. They remove those box from the box. Or wrapping, they remove the physical layer, they remove its own header, then say, oh, data link reads the information, and then it gives to the network layer, network reads its own information, and then hands over to transport layer, and transport say, oh, this is for this application, and is going to unwrap that and is going to give it to the next layer. That's how the communication flows. So encrypting from this way and decrypting on the destination. So these are called OSI standard model. The way the information is being formulated, the firmware are used for compatibility is open standard. Because why they have to make it open standard? Otherwise, if the vendors or the manufacturer are creating their own, you have to buy a license, you have to pay them. And TCP/IP, we will see that it is not open standard, which is my next lecture tomorrow. And I want to make sure, if you want to learn these things, read this one, and tomorrow follow my next lecture. Until then, bye and take care.